Okay, I'm going to show you you guys have heard of this? Yeah. It's kind of a cool thing. So here's what I get from the story. The story goes that the Greeks were in a battle for a really long time. It was like 10 years, and they couldn't win. And so they decided to siege a plan in which they said, it was at the city of Troy, and they said, all right, let's pretend we're just going to give up. Okay? And we're going to present them with this statue. It was like they win, and here's your statue. So they drag it up there, they set it out, and then they actually get in their ships and they leave. So the city of Troy, people see them, and they're not really waving at them, but they can see them going away. But then here was the plan. Okay, there were like Navy SEALs. That's like the quality of the guys that were in here. Okay, they were like the best of the best, were hiding inside of there. And when night came, they came out of here, went into the city of Troy, opened up the doors. They didn't fight them. They just opened up the doors. And then in the meantime, the people who were in the boats, the army when they left, well, they just turned around and came back. And the plan was then they could just go in. And they went in and they just destroyed them and they won the war. So when you hear of a Trojan horse, that's what it is. Now in computer terms, Trojan horse is a bad thing because it's a program that disguises itself as harmless, and then it gets in your computer, and then it does really nasty things like wipes out your hard drive or takes over your controllers, makes your computer really slow, stuff like that. All right, what we're going to study is the U substitution, or the integration by substitution. I want us to think of it like the Trojan horse. The key here is that there's something inside of something else. Okay? There's something inside of something else. It goes back to the chain rule. It's kind of like a Trojan horse, Trojan Russian doll, because there's something inside of there. Okay? Yes, this is a super Trojan. So that's what I want you to think about as we're doing this, because that's how we're going to apply it. Okay, so let's explore what's going on here. Before I do anything, I need to make sure that you can do basic integration. Okay, we have to be able to do this. So basic integration works with any variable, but for these, we're going to use the variable u, okay, because that's actually what they use on the AP exam. So let's just do a couple. These are basic integrations. Where instead of x's like we have been in the past, we're just using u's. Okay, give me the answer to those three, because they're just basic integrations. Okay, do we agree with all three? I mean, there's no difference if this had an x in it or a q or whatever. The variable right here tells you which one's the variable, and that's the one that we're integrating with respect to. Okay? All right. So you got to be able to understand that you can use any letter, in particular u, because that's what this is all about. All right. Let's take a look at why we might need a new rule. Okay, so now these are new examples that are different from everything else. So first one, let's integrate, let's say it's 4x minus 5 to the 43rd power. Four x minus 5 to the 43rd. Well, as far as I know, we only have this rule that says something that it has to be in the power form, power rule. So this isn't too bad. I'll just expand this. Then I'll get a sequence of individual polynomials. And then we'll just integrate each one of those. Easy. Okay. Well, in problem solving, we try to find as many approaches that we can and then choose the best one. That one seems like it might take a while. Okay. But I wonder if you can just apply the power rule for this one. Meaning, let's try it. That's how things work. You just try it. And if it doesn't work, okay, then you figure out something else. So if I were to apply the power rule here, what would we get? Well, I think you'd get something like this, 4x minus 5 to the 44th, right? And then it's 1 over 44. The question is that right? What is the derivative of this? The derivative of 1 over 44 times 4x minus 5 to the 44th. What is that? Four x minus 5 to the 43rd, right? But times 4, right? So it's close, but it isn't what we started with. But it's really close, isn't it? It's just this thing that throws it off. Okay? So, any guesses as to what that integral is, knowing that that 4 is left over? What is the answer? What is the real answer to this? Knowing that there's a 4 left over. Anybody? Yes? Okay. Christina, what do you got? What is it? Take the integral of the inside, too. Okay, you're close. But I don't think we're integrating the inside. Watch this. The derivative of the inside here is what? 1/4. Pardon me, is 4. So I'm taking the reciprocal of it. 1/4, I'm using this thing right here, times 4x minus, pardon me, I'm going to do the 1/44 times 4x minus 5 to the 44th plus c. Find me the derivative of that. Forty-fours cancel, right? And then the 1/4 cancels out the 4 when we take the derivative of it. So the derivative of this is equal to the 4x minus 5 to the 4/3. Okay? To the 43rd. Okay? Now, this is just us exploring this. Let me show you how we're going to actually handle this and where the idea of the Trojan horse comes in. Okay? Yeah. So now I'm going to do the solution using U substitution. Solution using, now this is a technique here, it's called U substitution. And it's actually a standard name, and we always use U. U is really important. U. It sounds like really bad grammar. U is really good. Okay, now, so when we see this, so I'm starting over. 4x minus 5 to the 43rd dx. Okay, this is what I'm starting with. But then I'm going to think Trojan horse. Okay? And I'm going to say this is actually equal to u to the 43rd. Okay? Whereby u is equal to 4x minus 5. Okay? This process takes a couple of steps, so you're going to have to learn all the steps. So the first thing is to recognize the Trojan horse and who's inside of whom. And the 4x minus 5, if you let it be u, then this is the same as this. Okay? The only problem is I can't bring dx down. I can't bring dx down because the variables have to match. I can't just say dx. I can't say, like, this is wrong notation. Okay? That's bad. Because then this says I'm going to integrate with respect to x. So where are my x's? Uh-oh, there's no x's because you can't see them. They're inside the horse. So the question is, how do I produce u's here, or a du, when I don't have a du? Remember that equations were born to be manipulated? This is a separate equation that's connected to this integral. What we're going to do is we're going to find the derivative of this equation. Okay? So watch this. I'm going to find the derivative of u with respect to x. Now watch. That means du dx is equal to 4. Found the derivative of both sides. Du dx equals 4. Now I've created a du and a dx, and they're related. That means I can substitute. So watch this. So remember these differentials, they're separable. So I'm just going to multiply both sides by dx. And I'm going to get du is equal to 4 dx. Now I'm almost ready to substitute. I want to replace the dx because that's the only thing that needs replacing. Well, if du is equal to 4 dx, dx is equal to 1/4 du. So it's 1/4 du is equal to dx, and now I'm ready to do my substitution. So in place of dx, I'm going to give its equivalent du, which is 1/4 du, which means this becomes 1/4. It becomes u to the 43rd times 1/4 du. Now watch how slick this is. We know that 1/4 is just simply a constant that's being multiplied here, so I can take it out. So this becomes 1/4 times the integral of u to the 43rd du, which is a super easy, basic integration, just like the ones we did on the front board. So let's do it. The 1/4 stays there. Now we do, what's the integral of u to the 43rd du? Well, that's easy. It's u to the 44th divided by 44 plus c. See what I did there? All I did was just basic integration. U to the 43rd, u to the 44th plus divided by 44. But then this is the final step. We started with x's. So that means we have to end with x's. So you're going to take your u and you're going to replace it with what its equivalent is. So the final answer is then 1/4 times the 1/44 times, parentheses, 4x minus 5 to the 44th plus c. And this is our introduction to U substitution, where now we're going to be able to do lots of problems in which there's a function hiding inside of another function, and our normal integration techniques don't work. We have to apply this chain rule concept to it. Okay? All right, we're going to spend like 2 days on this, and then we're going to move on to e to the x and natural log and apply U substitution to those. So you can start taking a look at your assignment, but I'm going to do a lot more tomorrow. Let's see. I think it'd be appropriate to be due on Thursday.